The dawn of November 24, 1944 broke clear over the Mariana Islands, where American airmen performed their final pre-flight checks on a revolutionary new weapon. From the tarmac at Northfield on Tinian and the airfield scattered across Saipan and Elliefield, the silver silhouettes of ULAN-11 Boeing B-29 Superfortresses prepared for their first major assault on the Japanese home islands. Brigadier General Haywood Hansell, commanding the 21st Bomber Command from his headquarters on Guam, had orchestrated this moment carefully. 277 tons of ordnance hung in bomb bays, destined for the Nakajima Aircraft Company's Musashino engine plant on Tokyo's outskirts. What would unfold over the next hours would expose a chasm between two nations' technological capabilities so profound that courage alone could never bridge it. Captain Tatsuo Yamada adjusted his oxygen mask in the cramped cockpit of his Kawasaki Ki-61 Hien at Chofu Airfield outside Tokyo. The morning briefing had been unambiguous: intercept the enemy bombers with every advantage altitude could provide. Intelligence reports spoke of enormous four-engine aircraft operating from the newly captured Mariana Islands, flying at unprecedented heights never before encountered by Japanese pilots. Yamada had volunteered immediately for this high-altitude interception mission, drawn by the challenge and the opportunity to prove himself against an unknown enemy. His fighter carried four 12.7mm machine guns and two 20mm cannons, weapons that had served Japanese aviation well in countless engagements across the Pacific. Yet those weapons had been designed for combat at conventional altitudes, where Japanese fighters traditionally excelled. The intelligence briefing itself reflected Japan's limited understanding of what was approaching. Earlier encounters with American heavy bombers during 1944 in China had involved B-24 Liberators and B-17 Flying Fortresses operating at altitudes between 20,000 and 25,000 feet. Major Tishi Meda had developed climbing tactics based on those experiences, emphasizing the importance of reaching altitude before the enemy arrived, rather than attempting to gain height during combat itself. A fighter already positioned above its opponent possessed energy advantages that no amount of defensive armament could overcome. But the morning's reports suggested something fundamentally different about these new bombers. They were operating far higher than anything the Japanese Air Force had previously encountered. The 21st Bomber Command represented America's most powerful Pacific deployment since the Doolittle raid of 1942. Eventually, this command would field over 1,000 aircraft distributed across 5 major airfields spanning Saipan, Tinian, and Guam. The revolutionary aspect of these aircraft lay not merely in their numbers, but in their fundamental design philosophy. Each B-29 incorporated pressurized cabins specifically engineered for extreme high-altitude operations across the vast distances of the Pacific Ocean. This construction approach differed fundamentally from everything that had come before. The earlier B-17 Flying Fortress and B-24 Liberator employed unpressurized crew compartments, requiring heavy flight suits and cumbersome oxygen masks that limited their effective operational ceiling to approximately 25,000 feet. American designers had made a different choice for the B-29, accepting enormous complexity in exchange for operational sanctuary above enemy interceptor range. The pressurization systems allowed crews to work in shirt sleeves at altitudes where unpressurized aircraft crews would struggle desperately against cold and hypoxia, their minds becoming clouded by oxygen deprivation. Yamada's fighter formation that morning included Ki-61 interceptors from the elite 204th Sentai and Nakajima Ki-444 Shoki fighters from the 47th Sentai, all climbing desperately from multiple airfields surrounding Tokyo at their maximum sustainable rates. Radar operators at the Chiba Detection Station tracked the incoming American formation at altitudes between 27,000 and 31,000 feet, varying their height as they navigated through weather patterns. Ground controllers frantically vectored the defending fighters toward the threat axis, but the climbing Japanese interceptors found themselves unable to reach even 25,000 feet before the bombers swept over their targets. The fundamental technological disparity became immediately apparent as the two air forces attempted engagement for the first time. Yamada's Ki-61 had been designed in 1941 for medium-altitude combat against Chinese opposition and early Pacific War enemies. His aircraft weighed 7,650 pounds and mounted a 1,075 horsepower Kawasaki Ki-40 liquid-cooled engine capable of producing 368 miles per hour maximum speed at 16,400 feet. While manufacturer specifications claimed a service ceiling of 36,000 feet, actual combat performance degraded severely above 28,000 feet. The engine lost power dramatically in the thin atmosphere, while control surfaces became increasingly sluggish and unresponsive. Self-sealing fuel tanks and pilot armor had been incorporated following earlier combat experience, but this additional weight further reduced the aircraft's already limited altitude performance. The Ki-44 interceptors from the 47th Sentai, which had been specifically designed for high-altitude interception with superior climb rates, found themselves struggling desperately in the thin air. Engines overheated while producing only a fraction of their sea-level power. Pilots gasped through inadequate oxygen systems designed for shorter engagements at lower altitudes. Most interceptors managed to reach 28,000 feet before beginning to stall, still thousands of feet below many of the approaching bombers. Those few fighters that achieved sufficient altitude discovered they lacked the energy for sustained engagement. Control surfaces barely responded in the rarefied air, and engines strained beyond their design limits, pushing cylinder head temperatures into dangerous territory. In stark contrast, the B-29s maintained formation integrity at their operational altitude with remarkable efficiency. Captain Robert Morgan commanded the lead Superfortress, Dauntless Dottie, as navigator Captain Theodore Van Cirk identified the primary target through the Norden bomb sight. Each B-29 carried four Wright 350 horsepower engines generating 2,200 horsepower each, maintaining speeds exceeding 300 miles per hour, true airspeed at operational altitude despite the thin atmosphere. Turbo superchargers compressed the thin air, maintaining engine power at altitudes where naturally aspirated engines would fail catastrophically. The pressurized compartments connected through a tunnel spanning the bomb bays, allowing crew members to move freely without altitude suits. This design philosophy enabled sustained operations at altitudes previously impossible for any combat aircraft. A central fire control system coordinated defensive armament through analog computers, tracking multiple targets simultaneously, while gunners operated from comfortable pressurized positions. Yamada pushed his Ki-61 toward its absolute ceiling, the airspeed indicator barely flickering above 180 miles per hour as the fighter wallowed in thin atmosphere approaching 30,000 feet. His pre-war training had never anticipated combat at such altitudes. The morning's mission briefing had emphasized attacking from above using diving passes to maintain energy. But reaching a position above the bombers proved impossible. Japanese doctrine, developed against unescorted B-17s and B-24s operating at moderate altitudes, proved completely inadequate for this new threat. The Hien could sustain 30,000 feet for mere seconds before stalling, forcing a recovery that cost 3,000 feet of altitude in moments. Multiple attempts achieved similar results as engine temperature gauges exceeded redline limits and oil pressure fluctuated dangerously. Yamada observed bomber contrails passing overhead, their defensive guns tracking his fighter but not firing due to extreme range. The altitude gap prevented any meaningful engagement, despite the Japanese pilots' desperate efforts and the early warning system that had provided ample time for preparation. That morning, only 40 Japanese fighters managed to achieve any attacks on the bomber formation, and most accomplished only single firing passes before losing energy entirely. Machine gun rounds fired in climbing attacks lost velocity rapidly in thin air, many falling short of their intended targets. The few fighters reaching effective firing position possessed insufficient energy for sustained engagement, managing only brief bursts before stalling away and tumbling helplessly downward. Anti-aircraft shells exploded thousands of feet below the bombers despite maximum elevation settings on the guns. The largest Japanese anti-aircraft weapons could theoretically reach 30,000 feet, but accuracy at such altitudes proved virtually impossible. Shells dispersed wildly, and the probability of a hit became vanishingly small. The November 24th raid marked the first mass B-29 attack on Tokyo since the symbolic Doolittle raid 31 months earlier. The formation maintained course toward the Nakajima plant, Japan's most important aircraft engine manufacturing facility. Chief Bombardier Lieutenant Coleman released his bombs on signal, followed by other aircraft dropping in sequence from their varying altitudes. Powerful jet stream winds discovered at altitude, reaching over 200 miles per hour, created an entirely unanticipated problem. Only 24 aircraft hit the primary target, with others bombing secondary targets or missing entirely due to the wind's unexpected force. Yet the psychological impact on both Japanese leadership and defending pilots proved profound and immediate. The bombs fell from unprecedented altitude, while Japanese fighters circled helplessly below, unable to reach the attackers. Ground observers watched vapor trails crossing Tokyo's sky at previously unimaginable altitudes beyond the reach of any defending fighter. One ramming attack by a damaged Japanese fighter, a suicidal gesture of desperation, claimed a single B-29 as the only loss of the day. Lieutenant Kenji Tanaka, coordinating fighter operations from Sector Control, received increasingly frustrated reports from interceptor squadrons. Pilots reported engines failing, controls becoming ineffective, and an inability to sustain the altitude necessary for interception. The bombers proceeded through Japanese airspace, suffering minimal damage from defenses while defending pilots expended fuel in futile climb attempts, most returning to base without ever reaching firing range. The technological superiority displayed shocked Japanese military leadership and pilots alike. The 21st Bomber Command concluded its first Tokyo mission with minimal damage from defenses, though mechanical issues forced several B-29s to divert or ditch in the Pacific. Japanese fighters claimed only one confirmed victory through ramming, while bomber gunners claimed 5 Japanese fighters destroyed. The altitude sanctuary contradicted every Japanese expectation based on intercepting lower-flying bombers from China bases. This operational failure stemmed from fundamental misunderstanding of American bomber capabilities and the revolutionary nature of the B-29's design. Lieutenant Commander Minoru Gender observed B-29 operations from Naval Headquarters, analyzing Army fighter failures with growing concern. His intelligence reports emphasized the unprecedented bomber altitude that exceeded Japanese interceptor capabilities by significant margins. Even the Navy's latest fighters could not effectively engage at such heights. The strategic implications suggested requirements for completely new aircraft designs or alternative defensive methods. But Japan lacked both the time and the resources for such development. The intelligence failure reflected limited technical information about American pressurization technology and turbo-supercharged engines, innovations that had transformed high-altitude operations. Japanese planning had assumed enemy bombers would operate at conventional altitudes below 25,000 feet, based on all previous experience. The B-29's pressurized cabin concept remained poorly understood by imperial military analysts who failed to grasp its implications for combat operations. December 3, 1944 brought another concentrated B-29 attack against Tokyo with 86 aircraft targeting the same Musashino plant. The Japanese response evolved based on the November experience. Captain Teruhiko Kobayashi of the elite 244th Sentai implemented new tactics, positioning his fighters at maximum altitude before the bombers arrived, hoping to dive on them with energy advantage. But even starting from optimal position, the Ki-61s could not reach bomber altitude. The formation included specially modified interceptors with reduced armor, removed radios, and minimal ammunition to save weight. These stripped fighters achieved marginally better altitude, but still fell short of effective engagement height. Lieutenant Saburo Hayashi led a specialized ramming unit called Hagakure Tai, formed from volunteer pilots willing to sacrifice themselves. The unit's aircraft stripped all unnecessary weight, including most armament and armor protection, carrying only enough fuel for one-way missions to achieve maximum altitude. The modified Ki-61 fighters climbed toward the approaching formation with emergency boost engaged, accepting certain engine damage. Manifold pressure exceeded manufacturer limits while cylinder head temperatures approached failure point. Pilots pre-breathed pure oxygen for 30 minutes before takeoff, but the inadequate oxygen systems still caused hypoxia symptoms during extreme altitude attempts. Most fighters stalled around 30,000 feet, still below effective engagement altitude. Sergeant Masaaki Itaki achieved 31,000 feet in his lightened Ki-61 before attempting a ramming attack against a straggling B-29. The bomber's defensive guns fired continuously as the fighter approached from below in a zoom climb. Multiple .45 caliber rounds struck the Ki-61, but Itaki maintained his collision course. At the last moment, his fighter lost energy, stalling 500 feet below target before entering an uncontrollable spin. The pilot recovered at 20,000 feet, his aircraft too damaged and lacking fuel to attempt another climb. The ramming attacks achieved occasional successes when bombers descended due to mechanical problems, but could not systematically counter the high-altitude threat. Through December 1944, B-29 losses remained minimal, while Japanese cities began suffering strategic damage. The defending pilots experienced profound frustration, watching their homeland attacked while remaining powerless to intervene effectively. Traditional samurai warrior spirit proved meaningless against technological barriers preventing combat engagement. Pilots reported feelings of helplessness and shame at their inability to protect Japan despite their willingness to sacrifice their lives. Major General Curtis LeMay assumed command of the 21st Bomber Command in January 1945, analyzing high-altitude daylight raid effectiveness with characteristic intensity. Initial missions achieved poor accuracy due to the jet stream winds discovered at bombing altitude, sometimes exceeding 250 miles per hour. These winds, unknown before B-29 operations, pushed bombers rapidly across targets, making accurate bombing nearly impossible. Navigation proved difficult, and while bombs drifted miles from intended targets regardless of bombardier skill, cloud cover frequently obscured targets during winter months, forcing radar bombing with minimal precision. The combination of factors meant less than 10% of bombs hit intended targets. LeMay faced pressure from Washington to produce better results. After analyzing the tactical situation, he implemented a revolutionary change in March 1945, ordering low-altitude night incendiary attacks against urban areas. This decision transformed the air war over Japan. B-29s stripped defensive armament except tail guns, carrying maximum incendiary bomb loads. The altitude reduction from 30,000 feet to 5,000 to 9,000 feet eliminated the jet stream problem while bringing bombers within range of Japanese defenses. The tactical shift meant Japanese fighters could suddenly achieve effective interception altitude, fundamentally changing combat dynamics. March 9, 1945 witnessed Operation Meeting House, the devastating Tokyo firebombing mission that reshaped strategic bombing doctrine. The attack force of 334 B-29s approached at 5,000 to 9,000 feet altitude, finally within reach of all Japanese fighter types. Night conditions and the unexpected tactical change initially confused Japanese defenses. Lieutenant Yoshio Mitsuyoshi scrambled in his Nakajima Ki-44 from Matsudo Airfield, finally able to reach bomber altitude without difficulty. But night combat presented entirely different challenges. Without airborne radar or effective ground control, Japanese fighters struggled to locate targets in darkness. Searchlights illuminated individual bombers, while anti-aircraft guns engaged at point-blank range for the first time. Ki-44s and Ki-61s conducted desperate single attacks without radio coordination or formation support. Mitsuyoshi achieved multiple firing passes against B-29s, observing hits on engine nacelles and fuselages. Several bombers streamed flames and lost altitude, but most continued to their targets despite damage. The Superfortresses demonstrated remarkable durability, absorbing tremendous punishment while proceeding to targets. Remote-controlled turrets engaged attacking fighters with radar-directed fire in darkness, proving surprisingly effective. Japanese pilots trained for daylight combat struggled with night engagement techniques. The incendiary attack created a firestorm consuming 16 square miles of Tokyo, killing an estimated 100,000 civilians in the deadliest air raid in history. Japanese fighters claimed 14 B-29s destroyed, the highest toll of the war, but could not prevent catastrophic damage to the capital. Low altitude enabled interception, but overwhelming bomber numbers, night conditions, and the surprise tactical shift limited defensive effectiveness. The success of firebombing validated LeMay's gamble, establishing a pattern for subsequent raids. The tactical shift invalidated Japanese high-altitude interceptor development programs that had been desperately pursuing solutions to the altitude problem. Resources devoted to high-altitude engine development and pressurization research became irrelevant overnight. Imperial Navy Lieutenant Sadamu Kumachi flew the new Mitsubishi J-2M Raiden interceptor during B-29 raids over Nagoya in early 1945. The Raiden's supercharged CSS engine enabled a 36,000-foot ceiling, theoretically sufficient to engage B-29s. But combat at extreme altitude proved nearly impossible even when fighters could reach bomber height. Controls barely responded while the engine produced minimal power despite supercharging. Pilots reported inability to maintain pursuit curves or lead targets effectively in the thin air, even when reaching bomber altitude. Fighters lacked performance for effective engagement. The Raiden required perfect positioning before bomber arrival to attempt even a single firing pass. Climbing pursuit from below remained impossible once bombers passed overhead. Many pilots experienced oxygen system failures, causing disorientation or unconsciousness at altitude. The few successful interceptions occurred against damaged stragglers descending from formation, not healthy bombers at operational altitude. April 1945 brought coordinated kamikaze attacks against B-29 formations. As conventional interception continued proving inadequate, the Japanese military formally organized special attack units specifically targeting B-29s. Corporal Koshi Ogawa successfully rammed a B-29 over Kawasaki on April 12. Both aircraft were destroyed in the collision. This same day witnessed one of the most celebrated acts of heroism in B-29 operations. Staff Sergeant Henry Irwin earned the Medal of Honor when a phosphorus flare exploded prematurely in his aircraft. The device burned through Irwin's face and body, destroying his nose and blinding him. Despite horrific injuries, Irwin carried the flaming device through the bomber to the cockpit window, saving 11 crew members. His sacrifice exemplified the courage shown by both sides, despite the technological mismatch. Special attack units formed at multiple bases, with pilots volunteering for certain death missions against the Silver Bombers. These ramming attacks achieved limited success, destroying perhaps 10 B-29s throughout the war, a tiny percentage of the bomber force. The psychological impact on American crews exceeded the tactical results, knowing that enemy pilots would deliberately ram their aircraft. Yet, even successful ramming attacks could not significantly impact the bombing campaign's effectiveness. The central fire control system on B-29s proved remarkably effective against Japanese fighters, despite reduced gun positions compared to B-17s. Computer-controlled turrets tracked multiple targets simultaneously, while gunners operated from pressurized compartments rather than exposed positions. Japanese pilots reported unprecedented defensive fire accuracy, with the automated system maintaining tracking even during evasive maneuvers. The remote control system allowed continued operation despite battle damage to individual gun positions. Unlike previous bombers where gunner casualties meant defenseless arcs, this technological advantage compounded the altitude sanctuary when bombers operated at maximum ceiling. The arrival of P-51 Mustang escorts from Iwo Jima in April 1945 further transformed the tactical situation. These long-range fighters established air superiority over Japan, making daylight B-29 operations even safer. Japanese interceptors had to contend with aggressive escort fighters while attempting bomber engagement. The few fighters that penetrated the escort screen found themselves pursued while trying to position for bomber attacks. Captain Yasuhiko Kuro commanded the 64th Sentai equipped with new Nakajima Ki-84 Hayate fighters, Japan's most advanced operational fighter. The Ki-84 achieved better altitude performance than earlier types, with a service ceiling of 34,450 feet under ideal conditions. Maximum sustained altitude reached about 32,000 feet with reduced armament and minimal fuel load. Pilots reported adequate performance up to 28,000 feet before dramatic power degradation occurred. The Ha-45 engine, though powerful at medium altitudes, lacked effective supercharging for extreme height. Ki-84s attempted intercepting mining missions where B-29s operated at reduced altitude over water, achieving several victories against bombers below 20,000 feet. These successes demonstrated the fighter's capability when altitude disadvantage was removed. But higher altitude daylight missions remained largely immune from interception, despite Ki-84 improvements. June 1945 introduced the Kawasaki Ki-300, a fighter converted from Ki-61 airframes with radial engines, replacing the troublesome liquid-cooled power plants. The modification improved reliability dramatically, but reduced altitude performance compared to inline engine versions. Ki-100s excelled against American fighters at medium altitude, proving highly maneuverable and well-liked by pilots. But the radial engine lacked high-altitude capability, limiting ceiling to around 32,000 feet. Pilots reported superior handling characteristics, but insufficient altitude performance for B-29 interception. The Ki-100 represented Japan's best operational fighter, but arrived too late and in insufficient numbers. Japanese aircraft industry produced various specialized high-altitude interceptor prototypes throughout 1945. The Mitsubishi Ki-83 twin-engine fighter promised exceptional altitude performance with turbo-supercharged engines. The Kawasaki Ki-102 heavy fighter carried powerful armament specifically for bomber destruction. Development programs suffered from material shortages, particularly high-grade aluminum and special alloys needed for superchargers. Manufacturing difficulties prevented operational deployment before war's end, with most prototypes destroyed in bombing raids. B-29 attacks systematically destroyed aircraft factories and engine plants, eliminating production capability. The Akashi engine works, producing the Ha-40 engine for Ki-61 fighters, burned in January 1945. The technological gap widened as American improvements outpaced Japanese development efforts with each month, bringing enhanced B-29 capabilities while Japanese industry collapsed. Lieutenant Colonel Paul Tibbets led special training for atomic bomb delivery, taking advantage of B-29 altitude capability. The silver plate B-29s stripped all defensive armament except tail guns, achieving even higher operational altitudes. These modifications ensured nuclear delivery aircraft remained completely immune from interception. August 6, 1945, brought the ultimate demonstration of altitude sanctuary. When Enola Gay approached Hiroshima at 31,060 feet, Japanese fighters launched from nearby bases but could not reach the lone bomber's altitude. Lieutenant Matsuo Yasui climbed desperately in his Ki-61, struggling to reach the enemy, his fighter achieving 29,000 feet before stalling, still 2,000 feet below the bomber. Other interceptors fared no better, with most failing to exceed 27,000 feet despite perfect weather conditions. The atomic explosion occurred while fighters circled helplessly below, unable to intervene or even identify the special nature of the weapon. Similar failure occurred August 9th, when Boxcar delivered the second atomic weapon over Nagasaki. Japanese radar tracked the bomber throughout its approach, providing ample warning for interception attempts. Multiple fighter squadrons launched but could not reach the B-29's altitude of 28,000 feet. The technological sanctuary enabled strategic weapons employment without any possibility of prevention. Post-war analysis revealed the full extent of Japanese technological disadvantage against B-29 operations. Pressurization technology enabled sustained operations above Japanese interceptor capability throughout the campaign. American crews worked efficiently at altitudes where Japanese pilots could barely survive. Engine turbo supercharging maintained power at altitudes where Japanese engines produced less than half their rated output. The accumulated advantages proved absolutely decisive in strategic bombing effectiveness. Japanese pilots consistently demonstrated remarkable courage and skill within the mechanical limitations of their aircraft. Individual determination could not overcome fundamental technological disparities in equipment capability. High-altitude combat required engineering solutions beyond Japanese industrial capacity during wartime conditions. Material shortages, particularly special steels and aluminum alloys, prevented development of competitive systems. The B-29 campaign validated American investment in advanced bomber technology and industrial capacity. Strategic bombing effectiveness depended on achieving operational sanctuary through altitude advantage that no amount of enemy courage could overcome. Japanese defensive failures demonstrated the importance of matching enemy technological capabilities in modern warfare. The campaign influenced post-war military aviation development priorities worldwide, establishing precedents still relevant today. General Korechika Anami evaluated home defense failures during final military conferences before surrender. B-29 altitude superiority negated Japan's geographic advantages and fighting spirit completely. Technical inferiority proved insurmountable, despite tactical innovation and pilot sacrifice. The recognition of technological defeat influenced military acceptance of unconditional surrender terms. Without the ability to defend against B-29s, continuing resistance became meaningless. Former Ki-61 pilot Lieutenant Naoshi Kano recalled desperate interception attempts in post-war memoirs. "We climbed with everything our engines could give, watching the temperature gauges go into the red zone. My flight leader's engine caught fire at 28,000 feet. He bailed out while I continued climbing, reaching perhaps 30,000 feet before my controls became completely ineffective." The B-29s passed overhead like silver ghosts, unreachable despite our most desperate efforts. The frustration and shame of being unable to protect our homeland haunted us more than fear of death. B-29 crew member Technical Sergeant Robert Johnson described observing Japanese fighters from his central fire control position. "We could see them struggling up toward us, tiny specks getting larger slowly. Sometimes they'd get close enough that we could see details, the red circles on their wings, even the pilot's canopy. Then they'd stall and fall away, tumbling like leaves. A few managed to fire at us, but their rounds usually fell short. It was almost sad watching them try so hard and fail. We had every advantage: altitude, speed, firepower, armor. They had nothing but courage. And courage wasn't enough against physics." Strategic Air Command incorporated B-29 operational lessons into Cold War nuclear delivery doctrine. High-altitude penetration became fundamental principle for strategic bomber employment against defended targets. Pressurization and supercharging technology advanced rapidly based on combat experience over Japan. The tactical advantages demonstrated against Japanese defenses influenced decades of bomber development, leading eventually to jet-powered strategic bombers operating at even more extreme altitudes. Japanese aviation industry studied B-29 technology through captured aircraft and documentation after surrender. Engineers recognized multiple technological generations, separated Japanese and American aircraft design philosophy. Pressurization systems incorporated complex sealing mechanisms and structural reinforcement beyond Japanese manufacturing capability. Turbo supercharging represented precision engineering requiring special materials and manufacturing tolerances unavailable in wartime Japan. Remote-controlled defensive systems employed analog computers more advanced than any Japanese military equipment, using vacuum tubes and precision components Japan could not produce. The technological examination provided sobering assessment of industrial development requirements for modern aviation competition. Veteran B-29 pilot Colonel Paul Tibbets reflected on altitude advantage during atomic missions. Flying above enemy fighter capability enabled precise navigation to target without defensive concerns. "We knew Japanese fighters couldn't reach us, which allowed complete focus on the mission. The technological sanctuary proved absolute. They could see us, track us on radar, but couldn't touch us. It was like being behind bulletproof glass." Their inability to intercept guaranteed atomic mission success regardless of early warning or preparation. Ki-84 veteran Captain Iwa Hayashi described attempting B-29 interception during war's final months. Despite flying Japan's most advanced fighter, reaching bomber altitude remained nearly impossible. The engine would cough and sputter above 30,000 feet, barely producing enough power to maintain flight. Controls became mushy like flying through molasses. We'd make one pass if lucky, firing a short burst before stalling. Watching them continue unharmed while our cities burned below created a sense of helplessness I'll never forget. Analysis of crashed B-29s revealed sophisticated construction exceeding Japanese manufacturing capabilities entirely. Pressurized compartment design incorporated complex sealing systems using synthetic rubber compounds Japan could not produce. Structural reinforcement for pressurization required precision welding techniques and quality control beyond Japanese standards. Remote turret control systems employed analog computers using vacuum tube technology more advanced than any Japanese military equipment. The servo mechanisms for gun control demonstrated precision manufacturing unavailable in Japanese industry. Even basic components like electrical wiring used materials and insulation superior to Japanese equivalents. Major Toshio Sakagawa commanded the 244th Sentai during B-29 offensive, recording unit combat experiences. My pilots were among Japan's best with years of combat experience, yet we achieved virtually nothing against B-29s at altitude. Our combat reports consistently described the same failure. Climbing desperately, reaching perhaps 28,000 or 29,000 feet, engines failing, controls becoming ineffective, then watching helplessly as bombers passed overhead. The technological defeat was complete and humiliating. B-29. Bombardier Lieutenant Marcus McDilder observed Japanese fighter attempts during missions over Osaka. The Japanese pilots showed incredible determination. We'd watch them climbing toward us for 15 or 20 minutes, struggling higher and higher. Some would try zoom climbs, trading speed for altitude in desperate attempts to reach us. They'd fire a few rounds, usually falling short, then stall and spin away. Our gunners rarely needed to fire. The altitude was better protection than any armor or weapons. It was a completely one-sided fight, determined by technology, not courage. Japanese military attaché reports from Germany described Luftwaffe difficulties intercepting high-altitude Allied bombers, providing context for Japan's struggles. Even with superior engines and technology, German fighters faced challenges engaging bombers above 25,000 feet. Me-262 jet fighters achieved limited success through speed and altitude performance advantages unavailable to Japan. Japanese industry could not develop equivalent jet technology before war's end. Despite recognizing the requirement, attempts to copy German designs failed due to lack of special materials and manufacturing expertise. The technological gap proved unbridgeable given resource limitations and strategic bombing damage to industry. Colonel John Montgomery led the 9th Bombardment Group missions from Tinian, observing Japanese defensive evolution. Initially, they tried mass interceptions, sending up everything that could fly. By spring 1945, they'd largely given up on daylight high-altitude interceptions. They concentrated on night raids when we came in low within range. Smart adaptation, but too late to matter. The altitude advantage we enjoyed for most of the campaign meant we could destroy their industry almost unopposed. Maintenance Officer Captain Hiroshi Fujiwara documented chronic problems with Japanese high-altitude fighter operations in technical reports. Engine failures increased exponentially during maximum altitude attempts. The Ha-40 engine in Ki-61s would overheat within minutes at full throttle above 25,000 feet. Oil pressure dropped. Coolant boiled despite radiator modifications. Oxygen system malfunctions caused numerous pilot casualties. Men passing out at altitude, some never recovering consciousness. Frostbite became common as pilots removed gloves to manipulate controls at extreme altitude. The cumulative mechanical failures made sustained high-altitude operations impossible, regardless of pilot determination. B-29 Engineer Staff Sergeant James Pearson monitored pressurization systems during combat missions. The cabin altitude stayed at a comfortable 8,000 feet equivalent while we cruised above 30,000. We worked in shirt sleeves, moving freely between stations. Meanwhile, Japanese pilots were struggling with frozen controls, inadequate oxygen, and engines that could barely function. The technological mismatch was absolute. It wasn't a fair fight. It was barely a fight at all. Japanese radar operator Corporal Shigo Yamamoto tracked B-29 formations approaching at unprecedented altitude. Our equipment could track them from hundreds of miles away, giving our fighters plenty of warning. But warning meant nothing when our planes couldn't reach bombing altitude. I'd vector fighters toward intercept points, knowing they'd fail. Pilots would report maximum altitude achieved, usually 27,000 or 28,000 feet, then watch bombers pass overhead at 31,000. The frustration in their voices was heartbreaking. We had the will, but not the means. Final Japanese military assessments acknowledged complete failure defending against B-29 high-altitude operations. Despite geographic advantages, warrior spirit, and early warning capabilities, technological inferiority prevented effective homeland defense. Industrial capacity limitations made matching American bomber technology impossible during wartime. The recognition of technological defeat influenced military support for surrender negotiations, acknowledging that continuing resistance could not prevent Japan's destruction from the air. Lieutenant Kunyohi Tanaka flew final interception, sortie August 14, 1945, against reconnaissance B-29, conducting damage assessment photography. His Ki-100 fighter achieved 28,000 feet before engine power loss forced descent, typical of hundreds of failed interceptions. The photo reconnaissance aircraft proceeded unmolested at 35,000 feet, documenting atomic bomb damage for American intelligence. The mission symbolized continuing technological inability to counter American strategic aviation superiority, even in war's final hours. B-29 radio operator Sergeant William Ale monitored Japanese fighter control frequencies during missions, providing insight into enemy frustration. We could hear their ground controllers vectoring fighters toward us, giving altitude and heading information. Then the pilots would report they couldn't climb any higher, engines overheating, losing power. Sometimes you'd hear anger, sometimes resignation. They knew where we were, knew what we were doing, but couldn't stop us. Technology determined everything. The United States Strategic Bombing Survey conducted extensive analysis of Japanese fighter effectiveness against B-29 operations. High-altitude daylight raids suffered minimal losses to fighter interception throughout the campaign. Approximately 50 B-29s lost to fighters from over 30,000 individual sorties, a loss rate of less than 2%. Japanese fighters proved effective only when B-29s operated at reduced altitude due to mechanical problems or tactical requirements. The statistics validated altitude sanctuary, effectiveness against contemporary interceptor technology. Former Imperial Japanese Navy Commander Masatake Okumiya evaluated strategic bombing defense failures in post-war analysis. The B-29's altitude capability exceeded our intelligence estimates by at least 5,000 feet. We expected maximum operating altitudes around 26,000 feet based on B-17 and B-24 performance. When they routinely operated above 30,000 feet, our entire defensive strategy collapsed. We lacked time, resources, and technology to develop effective countermeasures. B-29 pilot Colonel Robert Robbins described the psychological advantage of altitude sanctuary. Knowing enemy fighters couldn't reach us changed everything. We flew straight and level to targets. No evasive maneuvering needed. Bombardiers had stable platforms for accurate sighting. Crews stayed calm knowing the main threat came from mechanical problems, not enemy action. The confidence boost was enormous. We owned the sky above 30,000 feet, and everyone knew it. Ki-84 veteran Captain Yoshiro Aoki recalled watching B-29 contrails beyond reach. Each mission brought the same humiliation. We'd climb until our engines failed, achieve maybe one-third the altitude needed, then watch silver contrails drawing lines across our sky. Traditional warrior spirit meant nothing against aluminum and engineering. We were samurai with swords trying to reach the moon. The psychological impact destroyed morale more than combat losses ever could. General Henry Arnold evaluated B-29 program success despite enormous development costs exceeding the Manhattan Project. The strategic bombing campaign validated every dollar invested in advanced technology. The altitude sanctuary enabled precision attacks and atomic weapon delivery without prohibitive losses. We proved that technological superiority could determine victory without massive ground invasions. The investment in pressurization, supercharging, and defensive systems paid dividends that shaped military aviation for decades. Japanese aircraft designer Teo Doi analyzed Ki-61 limitations against B-29 operations. Our fighter was optimized for combat between 15,000 and 25,000 feet, where most aerial combat occurred. We never anticipated bombers operating routinely above 30,000 feet. Modifying existing designs proved impossible. The engine, airframe, and systems were fundamentally inadequate for extreme altitude. Starting fresh would require years we didn't have and resources that no longer existed. Squadron leader Major Teruhiko Kobayashi's 244th Sentai achieved over 100 victories against American aircraft, but minimal success against B-29s. My pilots included multiple aces with years of experience against fighters and medium bombers. We remained competitive. But B-29s at altitude might as well have been on another planet. Skill became irrelevant when your aircraft cannot physically reach the enemy. We watched our homeland burn while possessing the will, but not the means to defend it. B-29 Navigator Lieutenant Thomas Cartwright described the navigation advantages of pressurized operations. Working at altitude without oxygen masks or heavy gloves meant precise chart work and calculations. We could use all our instruments effectively, communicate clearly, move between stations as needed. Japanese navigators in unpressurized fighters dealt with fogged goggles, frozen instruments, and hypoxia affecting judgment. Our technological advantages multiplied effectiveness in ways beyond simple altitude. Japanese anti-aircraft artillery commander Colonel Hiroshi Yamamoto documented the futility of ground-based defenses. Our largest guns could theoretically reach 30,000 feet, but accuracy at that altitude was nearly impossible. Shell dispersion patterns meant hitting anything required incredible luck. We fired thousands of rounds per bomber destroyed, depleting ammunition reserves without meaningful effect. The B-29s flew above effective ground defense capability, protected by altitude as effectively as any armor. Maintenance challenges plagued Japanese high-altitude operations throughout the campaign. Engines required complete overhaul after just a few maximum altitude attempts due to excessive stress. Supercharger systems failed regularly, with replacement parts increasingly unavailable. Oxygen systems needed constant maintenance while suffering from inadequate supplies of oxygen bottles and calcium hydroxide for carbon dioxide absorption. The mechanical attrition reduced available interceptors regardless of combat losses, creating a downward spiral of capability. B-29 tailgunner Sergeant Robert Goldsborough observed Japanese fighter attempts from his isolated position. From the tail, I had the best view of Japanese fighters trying to reach us. They'd appear as specks, slowly growing larger as they climbed. Some would fire from extreme range, their traces arcing up but falling short. Others would try zoom climbs, trading all their speed for altitude. They'd hang motionless for a moment, almost reaching us, then stall and tumble away. I rarely fired. They never got close enough to be a real threat. The technological mismatch extended beyond simple altitude to every aspect of aerial warfare. B-29s carried sophisticated navigation equipment, including radar and radio navigation aids unavailable to Japanese forces. Communication systems allowed coordinated operations across hundreds of miles, while Japanese radios frequently failed. Even basic equipment like heated flight suits and optical gun sights demonstrated American industrial superiority. Japanese industrial mobilization could not match American production capability despite desperate efforts. B-29 manufacturing incorporated precision techniques and quality control beyond Japanese capability. Assembly line production achieved economies of scale impossible with Japanese cottage industry methods. America produced nearly 4,000 B-29s while Japan struggled to manufacture hundreds of inferior fighters. Attempts to replicate captured equipment failed due to material science limitations. Japan lacked access to special alloys, synthetic materials, and precision manufacturing tools required for advanced aviation technology. The industrial technology gap proved insurmountable given wartime constraints and resource availability. Lieutenant Commander Masahiko Kawamoto led special attack units against B-29 formations over Nagoya. We modified our tactics constantly, trying everything imaginable: night attacks, dawn interceptions, coordinated ramming attempts. Nothing worked consistently. The B-29s adapted faster than we could, changing altitudes, routes, and tactics. When we finally developed techniques for night interception, they switched back to high-altitude daylight raids we couldn't reach. They held every advantage, while we only had determination. Boeing engineers designed the B-29 specifically for Pacific Theater strategic bombing requirements against Japan. Extended range enabled operations from distant bases beyond enemy interdiction capability. Pressurization allowed routine operations at altitudes exceeding enemy interceptor performance. Defensive systems provided protection without sacrificing performance. The design philosophy prioritized technological advantage over traditional bomber characteristics, creating a weapon system rather than just an aircraft. Post-war aviation development incorporated lessons from B-29 operations extensively. Pressurization became standard for commercial aviation, directly adapted from military technology. Turbo supercharging enabled routine high-altitude flight for all aircraft types. Remote control systems evolved into modern fly-by-wire technology. The technological innovations transformed aviation beyond military applications, establishing foundations for modern aerospace industry. Captain Kazunoda commanded Ki-84 Squadron during final homeland defense operations. Japan's most advanced fighter meant nothing against B-29s at altitude. Below 25,000 feet, we could fight effectively. Above that, we were helpless. Pilots would return from missions demoralized, having never fired a shot. The psychological damage exceeded our aircraft losses. We knew we were beaten technologically, which meant we were beaten completely. The B-29 operations vindicated American strategic bombing doctrine through technological superiority demonstration. Altitude sanctuary enabled systematic destruction of Japanese military-industrial capacity without prohibitive losses. Strategic effects achieved decision without invasion, validating air power theories. Atomic weapon delivery succeeded due to immunity from interception at operational altitude. The campaign proved decisive air power application through technological advantage rather than mass, establishing precedents for Cold War deterrence strategy. Japanese military leadership recognized technological defeat implications for continuing warfare. The inability to defend against B-29s demonstrated broader technological inferiority across all military capabilities. Industrial capacity could not match American production while suffering strategic bombing damage continuously. The cumulative recognition influenced Emperor Hirohito's decision, accepting unconditional surrender terms without means to prevent aerial destruction of Japan. Continued resistance became pointless sacrifice. Veteran B-29 crew, Chief Master Sergeant Frank Morrison, maintained aircraft systems throughout Pacific Campaign. The pressurization equipment was complex but reliable when properly maintained. Turbo superchargers required careful attention but gave us power at altitudes where Japanese engines wheezed. Every system represented years of engineering development and industrial capability Japan simply didn't possess. We won through technology and industrial might, not just courage. Former Ki-61 pilot Lieutenant Jiro Tanaka survived multiple unsuccessful B-29 interception attempts. Each mission demanded maximum physical effort, fighting altitude effects. Breathing became difficult even with oxygen. Hands went numb from cold. Eyes watered continuously from dry air and cold. Then watching bombers proceed unopposed while our cities burned created psychological trauma beyond combat stress. We felt we had failed our ancestors, our emperor, our people, not through lack of effort, but through technological inability. American industrial mobilization produced quantities and qualities of equipment beyond Japanese comprehension. The B-29 program alone cost more than Japan's entire military aviation budget for the whole war. Mass production achieved economies of scale impossible for Japanese manufacturing methods. Precision tools and quality control ensured consistent performance unavailable from Japanese industry. The industrial asymmetry compounded technological advantages throughout the strategic bombing campaign. General Curtis LeMay's tactical innovations maximized B-29 advantages against Japanese defenses. Low-altitude night raids negated altitude advantage but exploited other technological superiorities. Radar bombing, incendiary weapons, and mass formations overwhelmed Japanese capabilities regardless of altitude. The flexibility to change tactics while maintaining technological superiority proved decisive. Japanese adaptation could not overcome fundamental disadvantages in equipment and industrial capacity. The B-29 campaign transformed understanding of strategic air power application. Technology enabled effects previously requiring massive ground forces. Industrial capacity became as important as military strategy in modern warfare. The precedents established influenced military planning through the Cold War and beyond. Nuclear deterrence strategies built directly on B-29 operational experience over Japan. This comprehensive examination of Japanese fighter operations against B-29 raids reveals technology's absolutely decisive role in modern warfare. Despite extraordinary courage, tactical innovation, and desperate sacrifice, Japanese pilots could not overcome fundamental technological limitations. The altitude sanctuary provided by pressurization and turbo supercharging created an insurmountable advantage. When combined with America's industrial capacity for mass production of complex weapons systems, the technological gap proved impossible to bridge. The B-29's operational superiority over Japan vindicated American investment in advanced aviation technology, demonstrating conclusively that in modern warfare, technological advantage can prove more decisive than traditional military virtues of courage, skill, and determination. The campaign's outcome was determined in American factories and engineering offices as much as in the skies over Japan, establishing precedents that would shape military aviation development for generations.